So first of all, how many people remember the, like for example, area of a rectangle? If you want to do an area problem, you need to know like the formula for the area. What's the area of a rectangle? Look up there, it's already there. Yes?
Area is based on size by density.
Rectangle?
Sorry.
That's a triangle. Length times width, basically that's what it is. So let me do some simple area. So what I want to do is before we do all these area problem examples, I need to kind of explain to you some of these basic ideas and help you kind of understand what they're talking about first. So for example, if they give you something like this, okay, I have a big rectangle, and then within this big rectangle, there's a smaller one, and the question is find the area of the shaded region. How would you do that? Anybody have an idea?
You have to unbase it.
Oh, sorry. Here, is that better? Now you can see it. Sorry. So, what would the I gotta show you this part. There you go. I need to show that the length is 8 right here. Width is 10. Width, by the way, is how wide something is. So it goes from left to right usually. Okay. So, anybody know what the dimension of the smaller? How many people say is, let's see, 7 by 5? Raise your hand. 7 by 5? So, no? Nothing. Isn't this 7 by 5? Don't we just subtract 3 from 10 and 3 from 8? No, why not? That's why a lot of people actually, that's why I did this problem. Because people think it's 7 by 5. It is not. Why not? What is it? Sarah, what do you think it is? Not 7 by 5, but?
I raised my hand for 7 by 5.
Okay, but now do you see why it's not 7 by 5? Guess what? If this whole thing is 10, let's look at the length width first, okay? If the whole thing is 10, Sarah, and from here to here is 3, here to here is 3,
7 by...
is it still 7?
4 by 2?
It's 4 by
2?
2. 4 by 2 is correct. Why is it 4 by 2, Sarah?
You have to subtract.
Yeah, you gotta subtract twice, right? These 3's, right? That's all around. Why twice? Because, class, it's all around it, right? Does that make sense? So don't make that silly mistake of just subtracting the area that's being, I guess, decreased this time. Don't just subtract it once. You got it because it's all around. You have to subtract twice, right? It's going to be 10 minus 3 minus 3, not just 10 minus 3. It's got to be 8 minus 3 minus 3. Okay, so write that down. Okay. So did you write down that the area is 8 meters square? Isn't that just by 4 times 2, right? Now, why is it meter square, by the way? Why isn't it just 8 meters? Yeah.
Well, because technically it's 4 meters times 2 meters. So
Yeah, you multiply meters times meters, so that's why it's meters squared. That's why the area, right? The area's units are square because you're multiplying 2 units together. Very good. Now, you look at this one. I think, Sarah, this is what you maybe will start thinking about when you said. So now, do you see the difference between this now? What would then, if I have this picture, how is this different than the other? I still have 8 by 10 rectangle. Now, it is being decreased by 3 just from one side only, not all around. What do you think this is then? This time, the length and width, Sarah, will be what?
I get it.
This time is what? That's right. Say it again.
7 by 5.
7 by 5. This time is 7 by 5. Do you see the difference? Okay? And of course, the area is going to be 35 meters squared, right? We're not, right? It's very different than the other one, where it's being decreased all around. This time, just from one side only. Okay? So please keep that in mind on your homework tonight as you're doing these area problems that are written in words, okay? Do you think you have to really recognize which ones they're talking about, right? Is it all around or is it just one side, right? That's going to make a huge difference, right? If you think that they're talking about all around when it's just one side, would you get the right answer? No. Okay, so you have to know which type they're talking about. Does that make sense, guys? All right, very good. So that's why I wanted to kind of lay down some of these basic works for you. Okay. So let's go on to the next. So how about something like this? They say find the area of the shaded region. Now this time the shaded region is a little bit different than before. I'm not talking about the rectangle anymore. What am I talking about this case? Yeah. The area and the rectangle. The frame, if you want to say, I don't know. Sometimes it could be walkway. They like to do walkways of garden or something, or pond. Okay, anyway. You know, like there's a walkway around the, if you have a rectangular pond or garden, they have a walkway. Anyway, it doesn't matter. Yeah, okay, so how would you find this area? Anybody have an idea? How am I going to figure out? Because it's not a rectangle. I don't know a formula for frame, area of a frame. How do you figure this out? Oh, a lot of you have an idea. Yes, sir. What do you think?
Find the area of the bigger rectangle and the smaller rectangle and then subtract them.
Yeah. Why don't we find the area of the big rectangle and find the area of the small one? Then we get the frame, right? Later, I'll show you how to do this in a problem. But anyway, that's exactly right. So I even wrote this down. By the way, before I show you that. By the way, do I know the area of the rectangle inside? Yeah, this is the same exact problem as the very first one. What was the area of the one inside? 8 meters squares. What about then? What's the area of the big rectangle then?
35 meters.
Is it what?
35 meters square.
80 meters square.
Isn't it 80? Length times width, right? Isn't it 8 by 10? And the other, wasn't it 4 by 2? Okay, yeah. So the answer then is 72 meters squared. Isn't that right? Because we figured this out from the example 1, that the area of the rectangle inside was 4 by 2. And the area of the big rectangle is 8 by 10, right? So 8 by 10, which is 80, minus 4 by 2, which is 8. Now, what do you suppose I have the parentheses around this area and so forth? Do you think I need parentheses when I subtract?
Yes.
Yes, I do. Especially, this case is not that hard, right? Because you have a monomial inside it. But what if you had binomial? Then you need to distribute the negative. You see what I mean? So whenever you subtract, always remember you got to subtracting the whole thing. So you put the parentheses. Does that make sense? So be careful with that. That's why I don't really like subtractions, because you always have to be careful. Anyway, so that's example 3. Any question there? Okay. On your homework tonight, you're going to get something like this where there are many different types of kind of question, but I want to kind of go over majority of them right now. So they could give you something like where they have a rectangle that's 3 by 4, and they're going to increase the area of this by x all around. Oh, no, just let's say that you have a picture or something, and you want to put a frame around it, and then I want the frame's distance from the picture to the frame to be x. You know what I'm talking about?
I think I don't get it now.
Okay, so basically this is what I'm talking about. Sorry, it's nothing hard. Hold on. Something like this, all around like this. Okay, so if I had an area 3 by 4, if I were to increase, I don't know why I drew the rectangle the other way. Doesn't matter. If I were to increase this rectangle by x unit all around, wouldn't the length and the width be 3x plus 2x and 4x plus 2x?
No.
No? Some of you? No?
Wait, hold on.
Okay, so okay. Let me erase this. That's why. Okay, so it's nothing hard. It's just sorry. Maybe I
You should just keep it like that.
delete. Yeah. Okay, so all I'm saying is, okay, here, I had 3 by 4. Okay, that's good. I get to draw this again. 3 by 4. And somebody said, okay, let's increase the area of this rectangle by x all around, x unit. So to do that, all you have to do is you increase by x over here, increase this by x over here, and is that all?
No.
No, all around. So you increase by x, increase this by x. So you would have a bigger. Oops, if I could draw it better. You would have a bigger rectangle. Okay. What would then the dimension of this new rectangle be?
Is this the
Okay, that's not the important part. Okay, so what do you think the dimension of this? First of all, what about my length? What do you think my length will be this time? Yes, one person knows. 2? Because this is the kind of question you would have tonight. Yeah. Anybody? 2 people? That's it? No one else? Yeah, what do you think?
Wait, what did you say? What's the question?
Yeah, what's the length? What's the new length?
Oh, it's new length. 4 plus 2x?
Yeah, 4 plus x, right? Which is 4 plus 2x. Do you see why I get 2x?
No.
Yes? Because it's increased from both sides, right? Who could tell me the new width then? That's all I'm saying. Yeah. 3 plus x plus x, which is 3 plus 2x. Why is it 2 again? Again, it's all around, so there are 2 x's all around it. That's all I'm saying. Nothing hard. So is that okay? All right. Now, if they could increase it, guess what? They could also, look at this one. Area decreased by x all around. So if you had 3 by 4, you see how I could decrease the x by all around? Oh, let me not give you the answers. Oh, you can see it already. So if it's 3 by 4, if I'm decreasing all around, look at my new width. Isn't it 3 minus 2x?
Oh,
You-
yeah.
Yeah. Why is it 3 minus 2x? Now, why isn't it just 3 minus x? 2 people see it?
It's always me.
Let me erase that. Do you know what I'm talking about? Okay. Let me erase the whole thing. I had 3 by 4, right guys? Yeah? And now I am decreasing this by x, this by x. Is that all? No, everywhere by x, right? All around. So then I get a smaller rectangle inside. What is my width going to be? This width. Yeah. 3 minus x minus x, which is 3 minus 2x. Do you see my width? Oops, I wrote x. 2x. 2x. 2x, like that. It's kind of too small. 3 minus 2x, right? What about, I don't have space. What about this one? Can I write it over here? What's that going to be? Oh, not 3. Yes, one person? Anybody else? Everybody should know. How do you get, yeah, Eddie.
4 minus x minus x.
Thank you. 4 minus x, which is?
4 minus 2x.
4 minus 2x. Would you agree, guys? That's all I'm saying. Does that make sense? So I even wrote those down here. See, look at my length and width. Do you see why it's 2? You're adding 2x to both sides and then subtracting 2x to both sides? Because it's, why? Why are we doing 2x? Because it's what?
2 of them.
Yeah, there are 2 of them, either increasing or decreasing, right? Of course, when you're decreasing, it gets smaller than before. Does that make sense? Any question? Are we good? Is that the only way to increase and decrease the rectangle? Do they have to be always all around? Not quite. So type 1, so when you're doing your homework tonight, it could be type 1 where the area is being increased or decreased by all around. Or there's type 2, and can somebody guess what type 2 might be? Do you have to increase the area? Yeah.
Oh,
Do you have to increase the area by all around every time? No? So what's another possibility? Yes, sir, Shiani.
Increasing one side.
Just one side, so that's type 2. Okay, so type 2, and I can show you the answer here. Type 2, I don't want to show you the answer. Well, you have all the answers. So if I were to increase, first of all, you see how I increased just one side? I had 3 by 4, and it's being increased by one side only? That's type 2. Does that make sense? And so, if I just increase by one side, look at my width. Isn't it just 3 plus x? Right? Because you're just increasing by one side. Everybody okay with that? What about for my length? Isn't it my original 4 plus? Now, how long are we increasing this by? X. So isn't that the new length and width for the type 2 sort of problem? Can somebody guess what it might be for decreasing? If I had 3 by 4, and if I decrease, what's happening to the length and width? Let's say this whole thing was 3. Oops. Right, this whole thing is 4. If you were to decrease this by x, what's my width going to be? Now it's what, 3? Minus x. What about for new length? It used to be 4, you decrease by x, so it's what? 4 minus x. Is this idea simple? Does this make sense? Yeah, so on your homework, do you think it's important to understand which type they're talking about? Okay, if you think that they're talking about type 1 when they're really talking about type 2,